My name is Qingyun Duan. I'm a professor and chief scientist at the College of Global Change and Earth System Science at Beijing Normal University. Prior joining Beijing Normal University, I worked in the US for 25 years. First at the National Weather Service, then at the Lawrence Livermore National Laboratories. I'm a hydrologist. My research interest is on water science. Particularly, I'm interested in study how much water we have, how the water moves from one place to another place, and its availability to meet the needs of human beings and the ecosystems of this planet Earth. Water is an essential resource which enables life on the Earth and also distinguishes Earth from other planets which has no life. But even though water is important, we constantly struggle with the fact that sometimes we have too much water, other times we have too little water. And every year we have hundreds of billions of dollars of losses associated with water hazards, including floods and droughts. To advanced knowledge related to water would allow us to predict how much water we have, or where the water goes and comes, and will definitely help us to improve the quality of life for the people on the Earth. So that's why I choose this field. One of my current projects, actually, I think is a very interesting one, is a project called Sino-US Water Energy Nexus Project. So this project trying to study the relationship between water and energy. And a key aspect of this project is to develop methods for hydrologic forecasting and also using those new forecasting information to optimize the operation of reservoirs. As we know, reservoirs are very important for electricity generation. And in this project, one of the interesting aspects is not only we want to improve electricity generation, but also optimize the reservoir operation so we can sustain the ecosystem in terms of regulating the temperature. This project is funded by the Chinese Ministry of Science and Technology and also by US Department of Energy. We are going to use the state-of-art ensemble forecasting methods for the Sino-US Water Energy Nexus project. And this new forecast approach allows us to get not only the best, most likely scenario, but also the uncertain information that's needed for making a risk-based decision. I'm the leading editor-in-chief of the Handbook of Hydrometeorological Ensemble Forecasting. This is part of a major reference book series by Springer Nature. This is the first such reference book on the subject of hydrometeorological ensemble forecasting. The book is going to include 11 sections, 65 chapters. This book will cover all the different aspects that is related to hydrometeorological ensemble forecast, from the meteorological ensemble forecasting and its post-processing to hydrological modeling, hydrological model calibration, data assimilation, hydrologic post-processing, verification system, application showcase, and communication of forecasting information to users. And also it has a section on the fundamental of mathematical fundamentals of hydrometeorological ensemble forecasting. It's a subject which represents a new kind of approach in forecasting. And so it's very, very useful to the young aspiring PhD students who just get exposed to this field. The intended readership, including the university graduate students, young researchers, but also including practicing hydrometeorologists, the emergency and water resources decision makers. In terms of the practice of hydrometeorological ensemble forecasting, right now the Western country, including the US, the European countries, and Australia, they have already developed advanced operational system to perform ensemble forecasting. On the other hand, in Asian countries, and in South America, in Africa, we still mostly using traditional forecasting approach. I hope with the publication of this new book, we will stimulate the progress in other countries which will adopt this new kind of approach. Right now, I'm working in China. I hope I can play a positive role in promoting this new kind of forecasting approach in China and help China to develop better forecasting products which can help us to manage our water resources better.